Today we're going to work on 3.3, which has to do with lines. We've done a little bit of this. I think we did problems like this in the last assignment. What does it mean to be a linear pair? They create a straight line and they have to touch. So 1 and 2 would be a linear pair. If I were to have another angle out here, and I did like 9 and 10, so 9 and 2 add up to 180, but they're not a linear pair because they're not touching. Okay? So just because they add up to 180 doesn't mean they're a linear pair. They have to be right next to each other, they have to be touching, and then form a straight line. So what's another set of, what's another linear pair? Good. So 2 and 3 would be a linear pair. 3 and 4 would be a linear pair. 1 and 4, or the same thing on the other intersection. Yeah, I don't know how he did it, but it you're right, it did, but I don't know what he did. Okay, what are vertical angles? So whenever you have an intersection, opposite angles are called vertical. And so those two, those are the same size, and these are the same size. Okay? So vertical angles are always congruent. How do we know that? How can we guarantee that vertical angles are congruent? So it's actually pretty easy. I know that angle 1 plus angle 2 is equal to 180 degrees. Right? Well, I also know that angle 1 and angle 4 add up to 180 degrees. Do you guys see it? How do I know that 2 and 4 are equal? So I want to so this one says 1 plus 2 is 180. And the other one says 1 plus 4 is 180. The only way for that to work is if 2 and 4 are the same size. Right? Let's say that angle 1 was 100 degrees. If I had 100 degrees plus angle 2 is equal to 180 degrees, and 100 degrees plus angle 4 is equal to 180 degrees, well, 2 and 4 both have to be 80. So vertical angles are always congruent. Okay? Now, C asks something that was a little bit different from the last one. What does it mean to be supplementary? Supplementary means adds up to 180 degrees. Okay? So linear pair and supplementary are kind of similar. The difference between linear pair and supplementary is linear pair has to be connected. Supplementary does not. Right, if I had that 9 and 10 over here, 9 and 10. So angle 9 and angle 2 are supplementary. They add up to 180. They're not a linear pair because they don't touch. Okay? Are 1 and 2 supplementary? Do they add up to 180? Yes, so they are supplementary. Are they a linear pair? Yes, because they're supplementary and they're next to each other. Okay? So linear pair is just stronger than supplementary. They both mean 180, but linear pair also means they're adjacent, that they're touching. Okay? I don't think so. Okay. Number 2. We know that the measure of angle 3 is 51. Find all of the other angles. Good. So if I wanted to find angle 2, I know that 3 and 2 are a linear pair, which means they add up to 180. So 180 minus 51 is going to be 129. So angle 2 is 129. Full circle's 360. Okay. What else should I do here?
Sorry for the interruption, but teachers said health department is in the faculty room giving flu shots, and they'll only be there for about 10 more minutes.
So I know that 3 and 1 are vertical. So 1 has to be 51. And I know that 2 and 4 are vertical. So 4 has to be 129. Okay? Okay. Excuse me. All right, everybody watch this. I know some of you are working ahead, but part of this is a little bit confusing. What do I know here? Right, I know that z is equivalent to 10x plus 44. And likewise, I know that this would be 8x plus 64. So one way to do it, don't write this down. I could say all of these added together are equal to 360. So I could say z plus 8x plus 64 plus 10x plus 44 plus 8x plus 64 is equal to 360. And then I put all that together and I get z plus 26x, and then 64 and 44 would be 110 plus 64 is 174. Then I have a problem. I have two variables. Oh, okay. So I know that z is this big, so I could plug that in there and solve, and that would work. Okay? But let's not do it that way. Okay, that will work, but there's an easier way. If we can use fewer pieces, it will be easier to solve, but that way would totally work. Okay? Well, the problem we ran into was mixing our x's and our z's. Is there an equation we could write that only focused on z's or only focused on x's? So she's looking here. It's not equal. We don't know that they're the same size, but what do we know? They equal 180. They're a linear pair. So 10x plus 44 plus 8x plus 64 is equal to 180 degrees. Now we combine like terms. 18x plus 110 equals 180. Or not 110, sorry. 108. Now I subtract 108. And I get 18x is equal to 72. And then I divide by 18. And x is 4. Now what? So I need to figure out what z is. So we need to take our result of x equals 4 and then insert it into this portion of the equation. So z is equal to 10 times 4 plus 44. 10 times 4 is 40. 40 plus 44 is 84. What do you... So you mean if it was, if like this was gone? And there was a z here? Oh, so if this was here, what would you do? It depends. Let me look at yours. Well, so you have to have two that are in a line so that you can make those two equal to 180. So it'd be the same thing. It's just kind of twisted a little bit. But if these two are a linear pair, then you add them together and set them equal to 180. Because if it looked like this, you wouldn't be able to solve it. Yeah, that there are actually a lot of correct answers to that. So well, no, I guess so. I lied. Back up. Forget I said that. So you could set those equal to each other. So you could say 10x plus 44 is equal to 8x plus 64. That would work. You could, but it's not. You can't trust the pictures. So, yeah, you can do it. You just set those equal to each other, and then subtract x, 8x, and then subtract 44, and then divide by 2, and you would get x equals 10, and then you plug 10 in to figure out what z is. So, yeah, you can do it. All right. What about number 4? Every triangle has an angle sum of 180 degrees. So what? So x plus 43 plus 106 is equal to 180. So we subtract 106 and I get what would that be? 74. And then subtract 43 and I get 31. So x would be 31. Why doesn't that make sense? Money? Y equals 180? Oh, well, I'll show you. Watch this. So let's say that I drew this line out here. Okay? And then I'm going to take this line and make a parallel line right here. Right? Well, this angle and this angle are the same size. Would you guys agree? Right? And it turns out that this angle and this angle are also the same size. So we end up with a linear triplet. This one would be 43, and this one would be x. So 106 plus x plus 43 forms a straight line. And that's true with every single triangle. Whatever triangle you draw, you can build this picture. And then you match this one, and you match this one and this one, then you end up with a straight line. So it is actually true. Yeah. So that's how you know that they are 180, but we actually have lied to you guys. Whoever told you that triangles always add up to 180 didn't tell you the whole truth. That is only true on a flat surface like a piece of paper. But we don't live on a flat surface. We live on a sphere. So if I were to draw a picture of the Earth, and my drawing skills are amazing, by the way. Look at that. So imagine if you and I were standing on a North Pole, okay? And you walk straight south to the equator, okay? But when you are pointed in one direction, I am pointed in a 90-degree direction. So you are pointed this way, and I am pointed this way. And so I walk to the equator. So the angle between us is a right angle. When you hit the equator, the angle created by you and the equator is a right angle. But when I hit the equator, the angle created between me and the equator is a right angle. What do you notice? 90 plus 90 plus 90 is 270. So it turns out when you draw triangles on a sphere, you will always get a number bigger than 180. And 270 isn't the biggest one. You can go up into the several hundreds, like maybe even 700 or 800. The highest might be like 900. No, I don't remember. I can't remember how big the biggest one would be. So this rule is only true on a flat piece of paper, which is weird because we don't live on a flat piece of paper. So if you draw a triangle in the dirt in your yard, that triangle exists on a sphere. So the angle sum would be greater than 180. However, that triangle is so small compared to the size of the Earth that you wouldn't be able to tell. Okay, it's just too small. So turns out that most triangles that we draw on the Earth, we just pretend that the Earth is flat. It just makes our lives easier, even though it's not flat. Okay, so you can do number 5. You can do 6. Okay, so here's the question you were asking, right? So you need to set these two equal to each other to find x, and then you plug that answer back in to find z. All right, let me make sure we've done them all. Believe so. Okay, get to work.